Let me start with the presentation. The topic is agreements between enterprises digitized by smart contracts in the domain of Industry 4.0. And we present the University of Furtwangen, the University of Applied Sciences. So, I have to do some clicking. Okay. So to begin with the whole agreement things, we have to understand that there is a digital transformation in industry. And sometimes we hear of it, sometimes it not. It often depends on the domain which you are working on. I think the most of us are working in the IoT section, therefore we are very good connected to industry. And to go a little bit further, why is this kind of digital transformation done up to now? Because we have about, I would say, 20 years or more the technology which would be necessary for digital transformation, but the digital transformation is here or has started like 5 years ago, or the Big Bang was there. And one of the biggest part is that the people got knowledge about it, and they combined with things like machine learning, they understood that they can optimize existing business models or processes and to improve their costs. And furthermore, they investigated, especially in the last years with the digital transformation, that they can create new business models. And especially in this area of new business models, there comes up the cross-company business model. And a cross-company business model means, like the word says, that we combine different companies. So we don't use only our company and we have borders around our company, but we might make some kind of globalization, and we open the borders of our company to other companies and combine our knowledge and our capabilities. And a good example for it are also smart factories, for example. So I, as a company, have got some service which I can very good do or produce a product, but I'm not capable of doing everything perfect, because I'm not an expert in every detail. For example, if you work for a laser company, you're specialist in creating lasers, but you're not specialist for creating a whole production machine, because maybe we have some kind of drilling and something else in the whole production. Therefore, we have to cross our company knowledge and go to another company and combine us. And there are one of the biggest things there is security as themselves, but also in combination the security, reliability, and the traceability of logging and monitoring. Because as we can assume, if we imagine we work with another company together, there's a lot of information sharing. And information sharing always goes with GDPR, for example, or things like that. We have data protection and data protection regulation or things like that around us. And we have to prevent the data which we transfer to someone else, to another company, that this data is still secure. And therefore, we can also go a step further when we make cross-company business models and have to agree about the information sharing and do some kind of contracts. Usually the traditional contracts are paper-based, so you write down, you got some information about the product which we create, and you're not allowed to forward the information, for example. The same could be you get machine tool information, how much tools we created or how much products, and so on and so forth. And especially in the topic of blockchain is a technology which has some properties, and a lot of these properties fit very good in this cross-company business model. But we have to say that always when blockchain is used, we have to think about the use case quite specific, because blockchain cannot always be used and is not always the solution to every problem in the company, like some people say. And here I have also written some of the properties which are very good if we do cross-company business models. And one of it is immutability. So if we share information and we have this blockchain technology used, and we share some information, it's not possible that someone alters the information there, or someone says I didn't got the information or something like that, because it's immutable, it's written there, it's traced, it's locked, monitored, and so on and so forth. We have also distributed nodes. We have not just a single source of trust where we say this person or this institute or this server is trustful, because always if there is some kind of disagreement, that the person which owns the centralized trust service has much more power in the communication, because he can, for example, alter data sometimes, not always. Then we have also no third party. Like I mentioned, we don't need someone we trust or someone who is responsible for our communication, because we have servers and distributed servers. And the last point is also the self-execution. So it's not only possible that someone says, okay, I write down some information in the blockchain and I wrote it down, it's okay. We have to make it self-executing, so that the control of the data flow and, for example, the transaction of data or sorry, of money is self-executed, and we cannot alter them while after the contract was done and someone signed the contract. So the contract should be self-executed after it is signed. And the business model behind this cross-company business model is also often a hybrid business model. And the hybrid business model is a combination of traditional things like product sales, hardware, and software, but it also combines newer technologies like cloud offering, services via subscription, or also they pay only for the use quota. This is, I think, one of the biggest points also on such hybrid business models. We do not have to pay for 10 servers. We just have to pay for 5 servers because we use and need 5 servers. So we only pay our used quota. And if we look now at the operational requirements, if we make such a hybrid business model, cross-company capable, there we have centralized requirements or central requirements, which we always have to fulfill or should fulfill for a very good business model. And the one thing is the continuous chain of trust, which we can solve by using a blockchain. We have something which we trust, which is responsible for the contracts which are signed. We have to create some kind of contracts. At the moment, the contracts are paper-based, but in the future, they should be digitized contracts. So we reduce the amount of paper-based things. And furthermore, also altering of paper-based contracts and things like that, or that after a long time, the paper is not readable anymore, and then there is a lot of discussion. And the third point, which I already mentioned, is the data governance and data protection. We have to create some rules, some policies, how the data can be transferred, how the data should be secured, and which data should be transferred. And we used in our paper an example where we digitized the maintenance of a machine, but I will come later to this special example. So the hybrid business model, we said that it has different requirements. And part of these are the agreements which are necessary for the business model. So we have a business model. We say, okay, we combine our knowledge in laser technology and drilling technology, and the information of our produced part has to send to the other. And then we have to check which kind of agreements there are. And we found out and we defined 3 different kinds of agreements. So we not only said every agreement is the same, we created levels of agreement. And one is the service level. It's very, let's call it, in the IT operations area. An example could be the bandwidth. How much bandwidth can we use via the communication? We have the process level agreements. For example, what is the processing time of the production line? And things like that. Or for example, especially process information. So durations, timings, costs at specific parts. And then we have also the business level. And the business level, we said in this example, how many numbers of work pieces are produced. And all of them, if you look at these kind of agreements, can be, or at the moment they are paper-based, and all of them can be transformed into smart contract agreements. So smart contracts just replace the traditional contracts. But, and this is the essential point when we say, oh, we use smart contracts and they are very good and very usable and let's do it. They also have disadvantages, or let's call it challenges. If we have these challenges, we have to solve them. And I took some of the challenges which we identified and wrote them down here to show it to you what kind of challenges we have to look at. And some of them are the digitalization limitations. There are properties which can be very good written down on a contract. Someone writes down to start the production of this very expensive car, the machine has to be clean, otherwise the car is afterwards not clean enough, and things like that. And it's quite hard to add this to a contract. But when you add this to a digital contract, the possible solution is to try to find some kind of information via sensors combined with machine learning, that the cleanness can some kind of be defined, like not more than how many drill water is allowed to be on the machine when the machine executes or something like that. Then there is the paper conditional ambiguity. So it's quite easily, like the example before, we write down, use a clean machine or a good drill, and no one knows what is a clean machine, what is a good drill. It's quite similar to the first challenge. And there we also said we have to evaluate and find quantifiable values. Then we have the identity of blockchain participants. So everyone who is in the blockchain and wants to add information to the blockchain has to have some kind of crypto functionality. This can be from hashing to encryption to decryption and so on and so forth. And if we assume we have got simple sensors in our system, not all of these sensors are capable of doing this, and not all of them have crypto engines on them. So a possible solution is the usage of a gateway. It's also possible for doing a retrofit. Use a gateway as a proxy, and the gateway has the capability for the crypto functionality, and that gateway is connected to the sensors. So the sensors do not usually communicate directly to the blockchain, so they communicate to the blockchain via a proxy. The cross-company data breaches. So if we communicate with each other and the data leaves our company, and there we have the problem, how do we solve this problem? And one of the best solutions for us regarding lawyers and things like that is a non-disclosure agreement. So we agree that we do not show the information to someone else. I think this is the actual practice if we do some kind of data exchange. And then there is also the possibility not only that the other company publishes the data, there can also be some kind of attack on the whole system. And therefore the data which is transferred between companies has to be encrypted and signed. And then we have also the integrity of recorded data. The data should not be altered. And also furthermore, is it the correct data which we get? So if there should normally come a temperature and we should write down a temperature and we got 15 products are produced or something like that, then that's not correct. And so we have to do some kind of data validation before we add this data into the blockchain. And furthermore, there is also the possibility that the smart contracts are badly written. So the software developer makes a mistake and then there is a problem. And so there can be some kind of validation system for the smart contract. There are special programming languages so that the amount of failures is reduced, and furthermore the employees which do this writing of smart contracts need to be very good in their area and need to have the foundations to write smart contracts. Sorry. And now to our use case. We talked before about the hybrid business model, cross companies, and we use this to show one of these cross company use cases, which is a maintenance use case. And to come to this maintenance use case, I just wanted to show you that maintenance is not as simple as it's often as it's sometimes imagined. And maintenance itself can be divided into 3 groups, depending on corrective maintenance, improvement or improving maintenance, and preventive maintenance. So for correction, you have to exchange some parts, for example, because something is damaged. For improvement, you add new sensors so that the whole measurements are better, more accuracy, or more and preventive is we look into the future and say, okay, we have to exchange the drill or replace the drill because the drill will be damaged or will destroy the machine in 5 weeks, for example. And for this maintenance use case, there are also often a lot of stakeholders. On the one hand side, you see it on the left side by the machine. You have a machine operator, someone who has the machine in the production and lets the machine work. You have a machinery manufacturer who produces the machine. You have a spare parts supplier, which is responsible, like the name says, for spare parts. And furthermore, you have a service provider for maintenance. It's not always the machinery manufacturer who does the maintenance in the maintenance use case. And this is a very simplified graphic with not every maintenance stakeholder in this area. And so on the right side, we can see the use case which we took. It's a completely theoretical use case where we simplified a lot of the things. And we said we have got the machine operator and we have the service provider. And on the machine operator, there appears an error on a machine. And the second point is we have to detect this error, some kind. And when we detect it, we have to inform the service provider who is responsible for our maintenance. And the service provider has to send a technician afterwards. This technician has to repair the machine, has to do a documentation and finalization after he repaired the machine. And then the service provider, after everything is finished, has to send an invoice and the machine operator has to settle the invoice. This is the use case which we have taken to show the smart contracts or the usage of digitized smart contracts. And yeah, I know it's a very simplified use case, and we can discuss, I think, the whole day what kind of parts we should add to this use case. But we needed a use case, a very simple theoretical use case to show the benefits of smart pay or digitized contracts. Then we went a step further and we took the use case from before and wrote down some tasks. And one of our most interesting parts was the interaction which is necessary on a specific task. So, for example, if we have a company Z and it enters a maintenance service contract with a company X, we have a communication between the company Z and the company X or X. And the same goes, for example, if we have an employee and this employee checks the machine. So we have a communication between the employee and the machine. And this is in the middle of this table found, this interaction column. And on the right-hand side, we have the column with the possible failures, because we looked at the tasks which are necessary for such a maintenance use case. And there we found out that there are a lot of possible failures. Like I want to take some of them. For example, I talked about the check the machine. In real life, it can be that the employee hasn't done the check. He has looked at the machine but hasn't done a correct check. Or another part would be that the employee has done the checking of the wrong machine. And then there are other points, like the machine error was found by the employee, and then there is the possible failure that the error was not found, or that a wrong error was defined. Like sometimes this happens if you go with your car to someone who should repair your car, and the person says, oh, we have to replace the following parts, and the parts are replaced and the car is still damaged. And so we did this definition of the process above, of the use case. And it has about 10 steps, 10 tasks. And we also did the same for the maintenance use case by using smart contracts in combination with blockchain. We assumed in our use case that the blockchain itself is secured and is bug-free. I know this is not true, but we wanted just to show what benefits do we get if we use a blockchain which works quite properly. And especially in the interaction, we see that the blockchain is very often mentioned. It's I think the most often mentioned interaction participant. And so we can take out some of them. For example, we have also the company Z enters a smart maintenance service contract with company X and writes down it into the blockchain. So this is quite similar to the before. But now we have a big difference. In a smart environment where not only do we use blockchain, we also have to have a production system which is smart enough to be usable with blockchain. And so we assume that the smart machine, the machine is so smart that it detects the error. And when he detects the error, it sends the error in the blockchain. And the result is that the company which is responsible for the maintenance automatically gets the notification that some kind of technician should be sent to the machine to repair the machine. And so this is the second part which we have shown there, that the maintenance use case can also be done in a smart system, in a digitized system. And to come to the conclusion, so this is not everything mentioned which is in the paper, but in the conclusion we have shown that the traditional paper-based use case is quite error prone. We had got 20 error sources or 20 possible errors just in this small example. And one of the biggest points which we found out is always the human failure. And it can be a lot of human failures. It can start from writing down the wrong information onto the sheet of paper, and someone signs this data, and depending also on contracts. And then we have this smart contract-based use case where the blockchain does a lot of these contract things. And there we found out that we can reduce the error sources quite a lot. And in this example, we only had 5 error sources. And so we wanted to show that the usage of digitize contracts and the whole blockchain things for the production environment in these maintenance use case is very useful. And to the outlook, the things which should be done, and that's for sure, is to take a real use case if there is enough time and if someone has real use cases which they want to publish. Furthermore, we have to do implementation of the blockchain in this whole real use case, because this is not done up to now. And depending on these real implementation and real use cases, we have to do further analysis. So thank you very much for your attention. If you have any further questions, please ask now.